It's gonna be this.
Then you might want to avoid out. Okay, that's pretty good. That's pretty good.
So I'm sorry. What was it?
Integral from 0 to infinity e to the negative root y.
That's what 7-8 was. Oh my
That's coming from me
god.
next.
Yeah.
Alright. What homework is that?
7.3.
I have to do this chapter.
Guys, and the instructions just said find the interval or evaluate the interval.
Yeah, it was just decide if the interval converges or diverges,
Oh.
and then if it does, write what the value is. If it diverges, it does.
Okay. So this would look like, I mean, this would basically be this, correct?
Right.
Right? So that's going to be 1 over e to the y to the 1/2. Oh my gosh, so many levels of stuff. So to determine if it converges, you kind of have to know how quickly it's decreasing. Right? It needs to kind of decrease pretty quickly. You can get a feel for how quickly it's decreasing by taking the derivative of this, actually, which is funny. I can't remember off the top of my head if the book actually gave me kind of a recipe way to figure out if it's decreasing quickly enough.
This was from online homework.
Okay. But if it was going to converge, right? So I want to try to do this integral. What method do you think you should try to use?
Well, I believe I tried to just do it in my head and then imagine the chain rule coming out.
Okay.
But then my answer was wrong.
Yeah, because the problem with that is the interior function is not linear. So it's not it's not one you can tease out in your head.
Okay.
So this is not like a direct use of, because it would be if there was another square root down here or something. Because this guy's derivative is basically this, but there isn't that. So what other method might you try to use to integrate this?
5 parts?
You could try it by parts, right?
Probably so.
So, I mean, the only thing you can do is let u equal this,
Yeah.
correct? So if you let u equal this,
You just get the same thing.
no, right? Let's make this better.
Oh, wait, no, you're
What would du be?
that.
It would be that
Chain rule.
times the derivative of this.
Yeah.
Right, which will be
1 over 2 y to the 1/2.
negative 1/2. Ooh. And then
Yeah,
du
but won't
be,
it not be negative?
say again?
Will the derivative be negative because it's being raised to the negative y? So the derivative would be positive?
So it's e to the, e is its own derivative, and then
Yeah.
the chain rule applies to this. There's only one negative that gets introduced, it's from this guy. There's not two negatives that cancel.
okay.
Yeah. Now that, like you said, is getting pretty gross, because then you'd have to do uv minus the integral of v du, which is getting worse, right? Okay. So then you have to worry, okay, so is there a way to show, what is this going to? What's the limit? So I'm gonna wait and see if anybody, one huge thing that must happen, let me see if you guys agree with me on this. One huge thing that must happen, if the integral, let's just do 0 to infinity right now, for this. If that's gonna converge, what must f of x do? What must the limit of f of x be? Think about this real quick. If the limit as x goes to infinity of f of x was 0.00001, aren't you at some point adding this forever? And this is tiny, but if I add it 18 billion times, it's already big. And then 18 billion is nothing. I'm not anywhere near done. So what I really want you guys to understand right now, in order for the integral, an improper integral of a function, in this case 0 to infinity, in order for that to have a chance to converge, the limit of the function has to be 0.
And it is in this case.
What's the limit as y goes to infinity?
0.
No, it's -1.
It's 1 over e to the square root of y.
Uh-huh.
Which would eventually get to 0.
Yes, which eventually gets to 0.
That's what I.
That's
All right, I'm with you. I just want to make sure everybody's taking all the steps with us. So this does seem to have a chance to converge.
Nice.
Right? Okay, so let's come back to this. So real quick, I just want to make sure that everybody understood this requirement. This doesn't mean that it definitely does converge. This has to happen in order for it to have a chance to converge. Okay. So at least this has a chance to converge because this is true. The limit is 0. All right. But this is getting pretty gross, right? This would be uv minus the integral of v du, so there's a negative there, so it'd be plus y times y to the negative 1/2 is y to the 1/2, e to the negative y to the 1/2. The u sub won't work because the derivative of this is y to the negative 1/2, right?
By parts.
By parts again, if you, let me see if this makes sense to you guys. If you use by parts and basically say u equals this and dv equals this, you're sort of undoing what you just did, right? So you sort of get in this perpetual loop. So let me think. I don't think this one, so there's a really classic transcendental problem. It's this guy. This guy, it's impossible to integrate this guy non-numerically. So there's a class called numerical methods, where you learn better and better estimation. Well, I call them subroutines because they end up being parts of computer programs. And this one you can't do by hand. Nobody can do this by hand, right? Just something you have to crank out in the computer. This one is in that same form, so it's a little bit evil. I'm trying to figure out if they put something in the instructions that would give you a clue. I have to look at the, can you shoot me like a little message for a specific problem?
Sure.
Yeah, I want to
I
see.
don't believe there was anything in the instruction that just said, decide if it converges or diverges. If it converges, what is the value?
All right, okay. I'll
And
take a look at it because it's a little, it's rather very evil. Let me think. I'll have to take a look at it. I'm not sure if it sounds like it doesn't really give you any clue. This is the only real check we have to see if it might. If this limit was anything other than 0, you don't have to do any work
Right.
because it wouldn't have a chance. It doesn't get out of its own way.
Well, it was a two-part question. So I got it correct that it converges, I just couldn't find the value.
Oh, okay, so it does converge. Okay.
Yeah, I
Okay.
just couldn't find the value.
All right, well, let's look at it a different way. Let's try this. This kind of relates to, all right, so I was going to try to play with this. We might as well play with this real quick because it kind of relates to a problem that's on the practice test. Yes?
If you're trying to see, like, because you know it converges, couldn't you just, at a certain point, start plugging in values for y? Like, you could you could pick larger and larger y values to see as it tends towards infinity, because we're just saying it gets arbitrarily large. We can pick how large it gets. You know what I mean?
That won't help us because we have to still get the
Yeah.
indefinite interval so we can plug anything in, correct?
Mhm.
So one thing I do have to take care of right now is limit t go to infinity, right?
Yeah.
All right. Now, here's something about radicals. Let's see if this will help us. I think it will. If I let u equal negative y to the 1/2, right? And it seems like this shouldn't work, and I don't even know if it will. It's just something you can try. When there's radicals, there's a problem in the homework. It's like x to the 1/3, not in the homework, but on the practice test. X to the 1/3 plus 1 over x to the 1/3 minus 1. That's going to be exciting. So we're going to go over that with you. It was definitely basically the hardest problem on the practice test. So if you're tearing your hair out over that, sorry. It's just a weird problem. Does everybody see this? Do you see why this can't be just a direct u sub? Because I'm missing this guy's derivative. Okay. Well, let's see what this does. What's the derivative of this?
Negative 1/2 y to the negative 1/2.
dy. There it is. Do I have that in here? Okay. So let me show you what we can do. This is kind of nifty. I don't even know where this is going to go.
Natural log.
I can get the negative 1/2 easy, right? Let's see, like this. You work? Yes. So if I put a negative 2 out front, I can get the negative 1/2 piece easy. I'm gonna leave some room. Is that cool, everybody? So I'm gonna try to build what I need. And of course, this is just e to this. So watch what I'm gonna do. I need this. Yes? So if I just put it here, what do I have to at the same time do out here? So overall, I just did nothing.
1 over that.
Yeah, which will just be y to the positive 1/2. So this and this become 1. Is that cool?
Mm-hmm.
Yeah, I love it. So do you see, I just did nothing, right? Good, Jeff. Good job. But do I now have my du? Yes. And, okay. So this is du. This is e to the u, right? And this,
It's negative u.
negative u. So I can just make that plus, is that cool?
Mm-hmm.
Now that looks like a standard by parts, right?
Yeah.
Tripedelic. So that is related to that practice problem on the practice test.
All that was legal.
Tell me where it was illegal.
I don't know.
The only problem, the other problem with this, which is really definitely evil. Let's see. No, that's not even a problem. Okay, good. I thought they were being really evil, but when you plug a 0 and you get 1, right? Okay. Yeah, that's sort of not really a problem. Okay, I'm just saying there is a little bit wiggly stuff with this, because when y is 0, this is a 1 over 0, right? But the important thing I want you to realize is this, with radicals, do you see how this worked out beautifully? Since u is this, the derivative ends up, especially with a 1/2, it ends up being negative that power, right? So, and that's why this was possible. And this happens so often in mathematics. I know what I want du to be. If I just force that to show up and do what I need to do, so I actually didn't do anything. Sort of like completing a square. Add a 4, well, you better subtract 4, right? Yeah. I know I want this to show up. Put it there. That's got to go there to make it legal. And then you're like, holy shit, that's you. Basically. Weird shit. It doesn't feel legal. Yes?
Isn't that like kind of like what we learned in Calc 1, where you can kind of like manipulate like that du equation to
It depends on your teacher how much flexibility they showed you with the u sub stuff. Yes. So some teachers unfortunately show no flexibility. They don't show the next step. They don't even show solving for you so that you can do more than you thought you could, right? Yeah. This one's even rarer for somebody to show this here.
Yeah, I thought that was illegal to just ever plug back in a variable.
Yeah.
So again, I love you guys. It happens so often in mathematics where to be able to move forward, we add and subtract something, or we multiply and divide something, right? That happens all the time. Okay, I like it. Now this is a great example of a problem that I would, if I gave this to you on the test, I would give you some kind of hint. Because this is exactly the kind of problem that you'll just go in circles around, and I know some of you guys, because I had a good friend of mine that was exactly like this. For some of you guys, you just have to, you can't do 2 until you finish number 1. I don't know if any of you are like that. So if I put this problem number 3, and there's 8 problems or something, you're gonna be sitting there like turning around with this and just not letting yourself go. Anyway. So when I assign problems for homework, there are integration problems, like the one we were talking about, that are just beasts. They just, and I try not to give too many of those, but I need to give some. Because part of what you need to learn as you're doing mathematics is organizational skills. So you don't lose anything. And if you never get a problem where so much is happening and so much has to be kept track of, you don't get any practice for that, right? Anyway, okay. So this is what I would do.
Okay, I'll do that.
Come to think of it, when I first looked at this problem, I didn't know exactly what to do. Right? Yeah. And then I realized, wait a minute, it's exactly like the problem I want to do today. Okay. And that's weird. And as a teacher, I don't want this to happen too much, but I kind of like not coming into class rehearsed with certain problems, right? There are certain processes that I want to rehearse, so I can show you, the derivation of whatever rule. So I definitely want to kind of go through that before I come here, so I don't forget some step or whatever. But a problem, I kind of want you to see what I'm thinking of trying to do, because I kind of hate it. No, I really hate it when a teacher has problems and they're like, oh, no, and it's like 20 minutes. Oh, no. I'm like, holy shit. But at the same time, it kind of sucks for students when the teacher's like, well, then you obviously this, and then this, and then this. Yeah, okay, and then the next one, you obviously do this. It's because they did their problem like several times before class, right? Okay. Anything else I can kind of go off on a tangent about? Sine and cosine, okay.
That was a joke.
Oh, Jeebus, help me God. Well, you're gonna love the shirt I'm gonna wear on Wednesday. Yeah.
I have a question that was giving me trouble earlier.
Okay.
On the definite integral from 0 to 1.
Hold on, sorry. It's okay. 0 to 1.
Root x minus x squared dx.
Oh yeah.
Yeah, no. I was staring at that for like 15
What a
minutes.
visceral reaction we got.
Oh yeah, that one was weird.
Okay. Did anybody get anywhere with this? It sounds like several people tried.
I think I did. I don't remember this problem.
What number was that?
24,
24?
For what chapter?
7-3.
There's like a form, right? Or you just complete this form.
Yeah, okay, complete the square is a really good place to start. Right? Or a good thing to try. Right? Do you guys see why complete a square makes sense? We have a whole host of things that are like blah, 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 blah.
Yeah.
So if I can make this look like constant squared minus or function squared plus or whatever, that could fall into a trig sum. So let's really see what this is. Let's see. Take a negative out. Okay, make some room. Is that cool? Now it looks more like standard kind of complete the square thing. You're all in Calc 2. When fractions show up, you should not be fearful, because they're going to immediately show up, right? What do I need to add to this? Half of this, right? Half of this.
1/4.
Negative 1/2 and squared 1/4. So I got to add 1/4.
I got that for.
At the same time, I better do what? Did I actually just add 1/4?
No.
Is this actually x squared? Is there an x squared in this problem? No, there's a negative x squared, correct? So if I put a 1/4 there, what did I actually just do?
-1.
Subtracted, so I better add 1/4 at the same time. You got to remember the number out front. In this case, it's -1, right? Because I understood -1. Will affect what you put here, because it's affecting these the same way. So I don't know if you picked up on this, but completed squares come up several times. It is more important than you thought when you first learned it.
Could you have done x minus 1/2 squared? That would have been the same thing.
Yeah, I'm not done with this here. So let me kind of put it in order. I'm going to put 1/4 minus. And the awesome thing is this always factors like the first step. Half of -1 was -1/2. There you Now it looks like constant squared minus trig function squared. So what trig would that lead to?
Secant.
Sine.
Sine, right?
Oh
1
my
minus sine
God.
squared is? Cosine squared. Maybe?
Constant minus.
I really, okay, you always have the option to memorize some of this stuff. But my God, brain fills up quick. So it's all about which trig, this is constant squared. It's actually 1/4. Who gives a shit what it is? It's a constant squared. Minus a trig function squared. That's like 1 minus trig function squared. Which identity is that? 1 minus sine squared is cosine squared. Okay, so I know I'm gonna use a sine. If you wanted to, you could do a u sub here. You really don't have to.
I got minus u squared.
Well,
and
what
then
are you gonna let equal to what sign?
Sine theta? No.
Equals
Wait,
1/2 sine theta.
1/2 sine theta.
All right, 1/2 sine theta. What equals that?
U?
I don't equal that.
X minus 1/2 squared. No.
X minus 1/2, yeah.
Yeah.
Right? We normally let x equal something. Why? Because there's normally just x here, but there's not just x here.
Yep.
I need this to end up being 1/4 minus constant times trig. I gotta make this whole thing that. Okay, maybe. So what's dx? See how this just goes to 0? Who cares?
Yep.
Equals.
1/2 cosine.
That's right.
Yeah, yeah.
Is that enough to keep going with that?
No. Because I got there and I still didn't get it.
So now I'm gonna do this, and you guys can, I mean, this wouldn't be horrible to change these, but I'm just gonna keep them like that. Let's see what we get. We get 1/4 minus 1/4 sine squared, right? Is that cool?
Mm-hmm.
Because this is 1/2 sine, so squared is 1/4 sine squared. dx is 1/2 cosine d theta.
Oh, I see what happened. I dropped the plus 1/4.
So anytime you see, it doesn't have to be underscore, but anytime you see under square root, x piece and x squared piece, right? You want to put them together so then it looks like a trig sub 4. This is really no other way that we know of to do that. Notice I say that we know of.
Yet.
You don't know.
But even with other shit I know, I'd still do it this way. And now it's just a bunch of cleanup, right? Is that cool?
Yeah, okay.
Oh, how do you get this 1/4?
Say again?
How do you get the 1/4?
Right here? Okay. If I want to complete this square, so I want to add something to this, so it will factor like something squared like this. The steps I take are always cut the middle guy in half and then square it. This is what I have to add to make this factor like this. Why does that work? Real quick, why does that work? What is x minus 5 squared?
X squared.
Minus 10x. Plus 20.
How is this related to this? That squared. And how is this related to this? That double. So if I take half of this, I figure out what's here. And if I square it, I figure out what goes there. I mean, because that's how these things work, right? So that's what a lot of mathematics is. Yeah.
Give a box right there.
Where am I at? Whatever I was. Oh yeah, yeah. That's how a lot of mathematics works. Is you do several things and you try to see a pattern in it, so you can make a general rule or approach, right? So completing a square is just noticing the pattern of how these things work. Every damn time, the middle dude is twice this guy, and the last dude is this guy squared. So we make this completed square out of this method to force anything that has parts of x's to be nice something squared, because that's so much better. Maybe. Okay. And then, I'll let you guys finish that one out. You get your nice cosine squared, which at this point should be straightforward. Yes?
Oh, I had a question about a different concept. So I don't really understand Simpson's method.
Okay.
I just wanted to clarify because it said something about parabolas, but I'm not sure
Yes.
what to do with that.
So we did finish that lecture, I believe, right? We did.
Kinda.
kind of.
We didn't really go in depth on Simpsons whatsoever.
I don't even remember talking about Simpsons.
It was like literally 15 minutes. And it was all conceptual. We didn't talk about the equation.
Oh, but the equation is plugging shit in. So
Yeah.
I really want you guys to understand. Once you get the rule set up, it's just plugging shit in.
That's
That
hard.
can't be difficult. What's difficult is understanding why it works.
We have to memorize those formulas, right?
No.
No? You'll
No.
give them to us?
Do you notice in the practice test I just gave it to you?
You did?
Yes, at the very bottom.
No.
Okay.
True.
True. Okay.
Sweet.
So Simpsons says, oh, that's right, we didn't quite, can't remember now, we finished. No. So I got something and I want to know the integral from A to B. So instead of making trapezoids, instead of making rectangles, I actually make something that might follow a curve better. I make parabolas, right? So this is x0, x1, x2. So what I do is since a parabola has three parameters, yes? A, B, C. If I want to determine its equation, I need three pieces of information. That's right, we didn't quite finish that up, did we? Okay. So, I know right here, so what I want to end up doing is creating this parabola from here to here that kind of is able to fit the curve better than any straight line could. So what we do, all right, let me see if I can quickly, let's see. Yeah, you're right, completely forgot to come back to this. Because yeah, we shoved it in right at the end. Okay, let me see if I can come back to this. This is delta x, but just to make it easier to write a bunch of shit, I'm gonna call it h. Do you remember doing that? No? Okay.
I do.
Let me ask you this. If I picked this shape up and I moved it back, does it change the area at all? No. Okay, so what I'm gonna do, let me see. Yeah. I'm gonna pick it up and I'm gonna move it back and put this right in the center. So now it's gonna look like, let me see if you guys can pull this. Right, that's gonna be negative h, that'll be h, this will be 0. So I basically just moved it back x1 spots. Shaboo. So now a, x0 will be negative h. That's how far back it is. Yes, what distance is this? H. So if I make this go to 0, where's a? Negative h. Does everybody understand that right there? Okay, let me see if I can't. Oh boy, here we go. Let's see. Roughly the same idea. Sort of. Screw. That's right. Okay. So just this chunk is there. So this is there. It's not quite the same shape. Let's go. So we need to construct the equation of this parabola. Because how do I figure out? Let me see what I want to tell you with this. Oh, okay. So this parabola that I'm going to use to model this in red. Let's see if I can make this better. Okay, it's not the best. It's not the best. It's not the best. This and what I just drew is related to a flat line for Riemann sums, right? Because it just makes a rectangle, right? It's got the lines up and then it's good. So that if I drew the red line for that, it'd just be a straight line. Or for trapezoidal, obviously it would be a diagonal line that would make a trapezoid, yes? So instead of connecting dots with straight lines, I'm connecting them with a curve. So that it actually is able to hug the function better. Especially if I make all of this tinier, yes? In the limit that those go to infinity, of course, right? Just like in Riemann sums. Let me stop for a minute. Okay. So, how do I get the area under this red line? How do we get the area under the red line? Take the interval. What's the interval of this? From negative h to h, right?
A over 3x.
Yeah, so it'll be ax cubed over 3 plus bx squared over 2 plus cx evaluated from negative h to h. So notice something, this guy's gonna disappear because when I plug in h and a negative h, it's the same, and I'm gonna take a difference. So let's see that happen. Let's plug stuff in. All right, let me stop for a minute. The whole idea, we haven't figured out what this equation is yet, but I know it's gonna be quadratic. That's the whole idea. I wanna connect these points with a quadratic, right? And there should be another point in here for this guy, but it's all right. So this point would be negative h, f of negative h. Then I have 0, f of 0, and then I have h, f of h.
So in Simpsons, we covered 2 intervals with 1 parabola?
Yes, yes. So normally we construct just with 2 points, because I only need 2 points to draw a straight line, and the top of it is a straight line. Now I'm talking about a curve, and more specifically a quadratic, and in that case I need 3 points, yes. I lock it. Okay, so if I plug stuff into here, I'm gonna erase this guy. I really don't want to spend a ton of time on this, but I at least want to show you where this thing comes from real quick. So I'm going to plug an h in, right? Plus bh squared plus ch minus, plug a negative h in. Is that cool? This becomes negative, of course, because it's cubed. This is squared, so when I plug a negative h in, it's still plus. And of course, this is the same thing as this guy. So see how these cancel? Right? So then you get 2 of these plus 2 of these. So far, so good? Okay, yes?
Zero beyond the black curve.
Yeah. It's my horrible drawing. So curve fitting on the fly is an exciting thing. So this would probably have to be, this would probably be like a really fat parabola. See how it's a really kind of fat parabola? Yeah, so that that point should be on the line, on the curve. It's just this weird, any 3 points that aren't collinear define a parabola. If the points are collinear, right, that defines a line. The minute one of them's off, then you can fit it with a curve. Okay, maybe. Okay. So we just figured out the area under this curve, but we don't know what the curve itself is yet. So what information do we have about the curve? Well, let me see what I want to say here now. So we know that when I plug a 0 in, oops. Let me call this something different. Yeah, we'll just call it y. Let me think for a second. Up. Yeah, when I plug a negative h in, then I should get f and negative h out. I think I'm still missing something. Hold on. Rawr. So this is where I had my notes already last time. Shoot. Let's see. There's one piece I'm missing to connect this. Let me think for a second. Oh, wait. Okay. I'm just going to totally cheat. there's that percent, blah, 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 blah. Okay, okay, all right, that's where I'm being silly. That's, of course, it's fine, Jeff, okay. I thought this was wrong, but, this is what we're gonna call y0, because this is x0. So y0 equals this, y1 equals, plug a 0 in, so that would just be c, and y2 equals, plug an h in. Okay, so this is y0, this is x1, so this is y1, this is x2, so this is y2. And this is the area that we're trying to get to. I don't know if I want to call that anything, not really. Yeah, okay. Yeah, so this is where things get a little freaky. Just to jump to the chase, this is sort of like a system of equations. So what you would end up getting is this. And this is where, in my notes, I had where this came from. And I think we get, yeah, this is the connection that is hard to get to, but shoot. Because of this result, this, if you took one of these plus 4 of these, right? If you just add these together, you get 2c, let me think. Yeah, okay. Okay, so this guy, if I combine these guys in a certain way, I'm gonna get this guy. So if you do it this way, you get this is 6. All right. Oh, so then you get, and this is h over 3 times 2ah squared plus 2c. Oh, that's right, 60. That's, okay, this is the part of, all right, you guys are all like, what the shit is this guy doing? There's a ton of shit here, and I'm really sorry that I didn't come back to this before. Is this okay? I mean, I know the form of this is gonna be this, because the whole idea is I wanna make it quadratic instead of a straight line. So to find the area under that, I just integrate it directly. Number 1, yes?
So are you kind of saying that the sum of y0, y1, and y2 is the same as the integral of that parabolic formula taken from negative h to h?
So if I combine the right amount of each of these,
Yeah.
I get the same expression, except for an h over 3, that I got from this directly.
Mm-hmm.
So this, how can I get this if I don't know what a and c are, correct? But I know that's the answer. You guys with me? That's the answer. That is the answer right there for this one little piece. That is the area under that one. I know it is, because we just did it. The problem is, I don't know what the hell these are. So it's not really helpful, right? And your eyes are all like, yes, Jeff, it isn't. Now, the really cool shit about this, which I really hate that I didn't finish this up with you guys, is these, what are these? Are these things we can get? Yes, because I know what these are gonna be. I can just plug them into the function, correct? And like somebody out there made sure we saw, these are actually on the function. That is the function they give us. So can't I just plug the first thing in to get the output? So if I can relate this thing, which is the answer, this thing is the answer, with a bunch of shit in it that I can't get, if I can relate it to a bunch of shit that I can get, then I'm done. So look, so this is this. So then I just put this here. And that's the answer. This, and if you look at the rule, so then what's the next piece over gonna look like? It's gonna start at x2. And it's gonna do all the same stuff, and it's gonna look like plus h over 3 times y2. Do you see how they both use y2?
Yeah.
The next one's gonna start here and use y2. Plus 4 y3 plus y4, right? And if you look, everybody have your practice test? If you look at the rule, look at Simpson's rule? Doesn't it have y0 plus 4y1 plus 2y2?
Yeah.
Right? You guys see that? Doesn't it start off? It starts off with delta x over 3, yes? Y0, or f of x0, I'm not sure. I can't remember how it's written. I don't even have my copy. Plus 4 f of x1 plus 2, right? So this we did right here was the area of the first chunk. Didn't this go further? I'd have to do the next chunk and add it to this. Then I'd do the next chunk and add it to that. But now you see why Simpson's rule has 4, 2, 4, 2, doesn't it? 4's come from these pieces. 2 comes because these are used twice. That's where they overlap. Okay, maybe. Now, the whole point of this is just trying to improve the approximations. Because again, what we learned earlier, integral of e to the x squared. What did I say about that one?
It's bad. Sucks.
Can you do it by hand?
No.
So then what do you want? You want a really good approximation to it. Right? Left endpoint, right endpoint suck. They suck bad, right? Midpoint, a little better. Right? Trapezoidal is actually a little worse than midpoint, but Simpson's, oh holy shit. Simpson's is like awesome. So some of you guys might say, okay, then why don't we do a cube? Yeah, you can do a cube, holy shit. What's that math look like? Do you start to understand? So it's using better, right, you're always gonna get these straight lines, right? They go from the first input to the next input, correct? It's just how do you connect the top? Well, if you use a straight line, it's almost always gonna suck somehow. You can't approximate a curve. So you can actually use, in this case, we used a parabolic arch. So it has a better chance to follow the actual curve, right? Then you can actually use other functions to model that. And they might have even better approximation capabilities. Right, that's very much enough of that. I'll stop right there. I'll stop. But at least wanted to get to a point where you can see where all the 4s and 2s came from. Yes?
That's like, when we're doing these problems, say on the test, we're not solving that system.
No, my guy. Let's do a problem right now. I did not do the last problem. I purposefully didn't do it on the answer key. We're going to do it together right now. Somebody has to remind me what the problem is, though, because I didn't bring...
Integral from e to the root x.
Hold on.
Oop.
All right. Okay. Sorry. See, that's an example of trying to do a process on the fly. Never a great example. So, do it again, sir.
Integral from 4 to 0
4 to 0, I like it already.
of e to the root x sine x
Oh, yeah, it's even better.
dx.
Oh, yeah.
N equals 6.
And you want to use n equals 6. Okay. And some of you guys might realize n has to be even.
Yes.
Simpson's rule to work. If it's odd, then it doesn't really line up correctly.
Oh, Jeff, it's 0 to 4.
So again,
It's 0 to 4.
is it?
No.
Oh yeah, it's the other way around.
Oh, you said 4 to 0.
Sorry, that's my fault.
You were all excited.
I was wrong.
That's all right. Integral doesn't have to be. It could be 4 to 0. But okay, so this case is 0. Okay.
Yeah.
So this is obviously my f of x, right? What's delta x going to be?
4 over 6.
Yeah, so I've got to go 4 in 6 steps. So 4 over 6. So b minus a over n. That kicks ass. It hasn't changed yet. Is there a rule that does use it different? Yes, there is, but we don't know. So that looks really inviting. So now all of this problem boils down to plugging shit in, right? So let's be a little more specific here before you put it in the calculator. So I need to do f of what? 0 plus 4 f of 2/3, right? Take a step, yes? You guys with me? If you need a visual aid, so we're going from 0 to 4, but every step I'm taking is 2/3 big. So the first input is 0, the next input go up 2/3. All right, that looks exciting. Plus 2 f of, what's the next one? 4/3, it's crazy. Plus 4 f of
6/3.
6/3 known as 2. We're halfway there. Oh, okay, sorry. Okay. Let me see, I don't know if I'm still in camera reach. Plus 2 f of add 2/3 plus 4 f of add 2/3. I'm about to get to 4, right?
Yeah, 12/3.
Yeah, I'm good. F of 4.
Wait.
There's no 2 on that 4. No. Again, because the very first piece isn't used twice. Because it's definitely by itself, and the minute you make that parabola, you're way away from it. But the next parabola reuses where that first parabola stopped. Yeah. And now it's just a matter of, let me try to show you a way to do this semi-quickly without having to write a bunch of shit down and then recopy it into your calculator, right? That's one of the most annoying things. And another annoying thing is, I think this room does not have.
It does not use my mind.
I think I actually have mine today, which is really neat. I do. Do it has battery, that'd be amazing. It, holy shit.
Yeah, with an empty
Okay.
Hmm?
That is just crazy.
Walking around with an empty cartridge. Should be using
At
everything
least
on.
turn that off. Okay, that should be good. Stay with me.
I've been awake for too long.
I understand that.
Not your fault.
No problem. I'm a math teacher, I'm used to it. Okay.
Nope. He said he was gonna shoot.
By the way, yeah, so
Freak
this would
out.
be 2 9s, is that cool?
Yeah.
So what I'm gonna do is I'm gonna do that inside, and then at the end I'm gonna multiply by 2 9s, so let's see.
Oh, if there's an easy way to do this, I'm gonna be kind of upset.
Oh,
Why is it 2 9s?
Because it's
Delta X
2 over 3 over 3. Yeah.
so let's see, let's do this. So let's put the actual function in here.
Oh man. Oh cool. Now I get to learn how to not type
This
it all.
word of x times, what was it?
Check out what my calculator does. Check this out. We have the same exact one. Yeah,
Okay.
but it's not. This
Yours?
thing is on a weird. This thing is on a weird.
Let's see how you guys feel about this.
Is this what you showed us last time?
It's terrible.
Not quite. I didn't really go this far as I'm about to.
That's
I don't know
weird.
how to take it off.
Down to go forward. So everybody's cool with that? Just plug the function in there. And then,
I don't know how
so
to
what do I
fix
need?
this problem.
Start off with, I need f of 0. So if I go to bars,
Bars.
y bars, you
Word.
only have to do this once if you do it the way I do
Bars.
it. And I want to get function, and I want to do y1. And I want specifically y1 evaluated at 0, right?
Bars. I meant bars. Why bars?
Now one way you could do this is to write y1 value 0 plus 4
Okay, can't
times
do it now.
bars, y bars, function, y1, right? Let me see. Does everybody understand? So I could do this. Plus bars, y bars, function, y1 of 2/3. I just keep going, correct?
Okay.
So I don't want to do that.
Oh, they're better.
There's nothing wrong with that really, but watch this.
They're better.
So y1 is 0 plus, here's that plus, let's see if you guys are cool with this. Actually, I haven't even tested this out yet. This should be exciting. 2/3.
It's always how it goes.
Plus that. Okay.
Oh, I see. Wait, hold on.
Yes.
So it gave me an error.
So now that's going to be y1 of 2/3 plus y1 of 0. And then I do, you can do a jump. I bring that back. So see, I don't have to, then I put 4/3 plus answer.
Don't you need to multiply it by 4 and 2?
Oh yeah, thank you. I knew I was going to forget something. Alright, let's try this. Oh, sorry. So you do vars, y vars, function, y1 of 0. Bam.
How do you bring back the last function that you just typed in?
Second enter.
Interesting.
Y1, so I want to do y1 of 2/3. And this is the one that's got to be 4. Yeah, that's why I wrote it up there, Jeff. Forget. So you immediately forgot. 4 times that plus answer. Bam.
Okay, interesting.
So now I'm here, right?
Mm-hmm.
So now I want to do, and again, this is up to you guys. Second insert, second enter. What's the next one? 2 times f of 4/3. So if I just keep that plus answer, it just keeps adding that. And also, if I just keep hitting second enter, I don't have to go through the vars menu to get the freaking y1. Now again, you don't have to do all of this. So if I did second enter, I want to go back. Where am I now? I'm now at the 2-1, right? So keeping track of where I am. So this should be a 4 times f of 2. Just to keep my fraction in there, I'm going to do that. Bam! I really want you guys to understand. So y1 of 0 sets that up. 4 times this plus what I already did. That's the second line. 2 times this plus what I already did. That's the third line. 4 times this plus what I already did. Yeah?
Mm.
And then now I'm at, where am I? I don't know. 2 times this at, what is it? 8/3?
Yeah.
8/3. Bam! And then I want to do 4 times this at 10. Oh, shite. Bam! And then I want to do, I'm sorry,
There's no.
1 times this. I just want one of these. Just make them 12. Calculator can do that. Okay.
Oh, it went down.
It went down, yeah.
Oh, because it's a
'Cause it's negative.
sine function.
Now, what do I still have to do? Is that the answer yet? What have I not done yet?
Divide by 9 and multiply by 2.
Yeah, multiply by 2 9. So now just times 2 9. Bam. Now, somebody write that down. This is so exciting. I'm so happy. I'm probably, let's find out how Jeff did. Does anyone know? I don't know if I've shown everybody here yet, but did your Calculus 1 teacher show you how to do an integral on your calculator?
Yeah.
Yes.
You
For
should
most of
know.
So if you haven't, you hit
Silly.
second trace to go to calc. By the way, somebody wrote that down, right? 4.685. You guys got that?
Yeah.
Okay. Second calc, and then of course number 7. It's going to try to draw this crazy ass thing. Look, there it is. And then I just want to go from what to what? 0 to 4.
You were very close.
What is it? Crap and a half. Look up there, Jeff. 4.6. Yeah, we got pretty damn close. Look at that shit. Should I have more faith, Jeff? More faith. There's so many places. Now, trust me, if I did give you this problem, you just have to capture this. And then you can do what we just did. But at least show me this. So that if you get this right, and it's just put in the calculator wrong, you'll lose much fewer points. So I grade heavy on concept. So if at some point you say 2 times 3 is 5, pretty sure you don't believe that. You're not going to lose many, if any, points for that, as long as you got the concept applied correctly. Shit, maybe. Which is why when people ask me, do I need a Scantron, I say, did I tell you guys, if you have a math teacher that says you need a Scantron for a test, they are not a math teacher. I don't know what they are, but they're not a math teacher, right? Because what's the most important thing for me to look at? It's the freaking work. Answer being right is a bonus right now, because you're not actually constructing bridges that can kill people. You're just doing problems on a paper, right? In the real world, you gotta get the answer right. Which is why we have all kinds of software and shit to kind of make sure that everything looks right. Okay. Okay. So now at least you have somewhat of a process to use in the homework, if you want to. Everybody with me on this? You guys cool? And again, just to remind you, I'm not even going to record this, but you could have done this problem like this. 2/9 times vars, y vars, function y1 at 0 plus 4 times vars y-vars function y1 at 2/3, right? You with me?
Yep.
Then you can kind of see it. Maybe some of you guys like that better. It drives me crazy when I have to keep going through the same menu over and over and over again, but nothing wrong with this. You can actually just keep going, right? Just put the whole damn thing in. Are you with me? Then you can see everything at once. You're not going to skip anything. There's nothing wrong with that. Okay. So if you're doing online homework especially, because sometimes it asks you to round it to use 6 decimal places. So if you use your table, the table only gives you like 4 decimal places most of the time. So that's not good enough, right? Okay. Enough of that. Where else do you want to go besides? Do you see how trapezoidal is the same thing? It's the same process.
Yeah.
Right? The concept behind it isn't the same because it's a line that connects them, but it's basically the same idea. Right? Get the areas of the shapes, add them all up. Okay. That is so desperately enough of that.
Can we do
What's the next thing? Yes.
Number 1.
Number
on
1.
the practice test.
Oh yeah, that'd be nice.
That would be nice.
Number 1 was a whole page.
Oh, sorry.
My calculator is spewing out different numbers.
Let me take your notes.
Do you have it in radians?
Yeah, because I was in degree 2 and I
Yes.
was getting all
So
confused.
it's got to be radians.
Because I had it in degree for physics. It's in
If
radians.
he's not in, I just
By
got
the
out of
way,
physics today.
I
It's
did
all-
hear somebody
everything's
tell me
physics.
physics
I
teachers
just
are
put it-
using
Oh, okay,
it
okay,
at
okay.
degrees.
Yeah, I get
Yeah.
It makes me really concerned. I don't understand that. Radians are actual physical measurements. You guys know what radians are?
Yeah.
What are they?
It's the look at the
Measurement of degrees.
along the circle with your pi values.
Interesting. Here's what it is. 1 radian is you take the radius of a circle.
This much.
You take the radius of the circle, take it out here, and bend it. And then you put it on the circle.
What?
However far that goes, that is 1 radian. 1 radius. So it's a physical length. You guys understand?
Mhm.
If I made this circle smaller, then the radius is smaller, I bend it, and it still goes to right there. Yes? To make the circle bigger, radius is bigger, and it still goes right there. Right? So it's a physical measurement. It's walking along the circle. What are degrees? Why is it 360? Totally arbitrary. We just liked the number 360 because you can break it up easily. It could have been 400. It could have been 2.
It's
Do
fun.
you guys know this? Anybody? There's
Yeah,
nothing special about 360.
In the trig review thing, that's what the teacher said. It's big.
Well, it's 'cause it was
It's
relational
easily
system.
divisible in a lot of different ways. And then, which is why we use it for our minutes and seconds, right? 60, 60. Maybe? You stole it from the Babylonians. Yeah, exactly.
Yeah, base 12 system.
Yeah, base 60.
Well, I
Okay.
thought it was.
All right, guys. So what's next? I'm sorry. Somebody had a number 1.
Number 1.
I still
That's
remember
right.
her
Very
name
good.
was Susan.
Here we go.
It was 4
I was gonna
points.
say you could run all the, cause I was stepping in and out, like I would work on it for like an hour, step out, and then I came back, worked on it for an hour, yeah, like worked out, and then. So I finished,
Oh, you did?
the rest of 7-2, I finished 7-3. A good portion of it.
But see, when you say answer, answer
Seven four.
is constantly updated. Yeah, so then you have to kind of start over. It's the bad part about A and S is it's constantly becoming the last thing. Yeah. All right, guys. So number 1.
I'm ready.
Totally.
Yeah, I literally saw the
Oh.
practice test.
Oh, number 1 was
One,
this
like,
guy. All right.
I
So,
really not
guys, what's this gonna look like?
It's gonna be A over x minus 1 plus B over x minus 1 squared.
Yeah.
I got that
B
far.
over x squared. Oh, plus C plus D.
Good.
Yeah.
What was it?
X squared plus X plus 1.
Yeah. Irreducible quadratic.
Yeah.
Ja. And this shit
Get a
over that, right?
Yeah.
Okay.
And then you just
if I multiply everything by this, he's gonna pick up another x minus 1, because 1x minus 1 is gonna cancel. So he picks up an x minus 1, and he picks up an x squared plus x plus 1. I really want that to be very straightforward. When I multiply by it, the only thing that cancels on this guy is x minus 1. So he picks up one of these and one of these. Here, both x minus 1s cancel, so he just picks up one of these. And here, the trinomial cancels, and he picks up these two things. And that's going to equal the top, which was x cubed 13x squared
Plus 8x plus, or minus 5.
Thank you. Remember, this came out nice, Jeff? Yeah, it came out nice. So, one thing you could do right now, before you start making your ABCD stuff and going insane, is there a thing I can use that alternate method? Is there a value of x that will help me? There's only one, and it's 1, right? So if I let x equal 1, this will be 1 minus 13 is negative 12. Let's say is negative 4 minus 5 is negative 9. Is that right? Okay. This guy dies, yes, this whole thing dies, because when x is 1, this is 0.
B equals negative 9.
This is 0.
Wait, no.
Twice over. And this is 1 plus 1 plus 1 is 3.
So B equals negative 3.
B is negative 3.
Okay.
You don't have to do this, but my God, anytime I can, I do. And when can't I? If there was nothing but this kind of shit. This root is some funky ass complex number, yes? If you try to do quadratic on this, do you want to let x equal one of those things? No, don't, right? So, dear God, whenever I saw a linear piece or just a nice thing that has a 0 to it, I'm like, oh, thank God. I can do at least one of these. Can I do any more of these? Are there any other x values? No, damn it. All right, too bad. So here's what you do immediately. We know what b is, yes? So this is actually
A
negative 3x
equals
squared
1.
minus 3x minus 3, yes?
Yeah.
So let me just add that shit over. I know what b is. Let me get that thing out of the way. Do you guys see that? Now you do. You might not have realized you can do that before, but use what you know. So add 3x squared, so this will be minus 10x squared, right? Add 3x, add 3. And what do I have left? Now I gotta start multiplying shit out. Oh God, x cubed minus x squared plus, oh yeah, this is a difference of cubes. I don't know if you guys noticed that. And this is over there now, yes? And then I have, oh God, all right. Cx minus, let's see, cx plus d times x squared minus 2x plus 1. So I get cx cubed minus 2cx squared plus dx squared. Right, and then, oh Jesus,
That
Jeff.
would be 2dx squared, 2dx squared.
Did I say that and then I didn't do it? All right, Jeff, don't do it too quickly. Cx cubed minus, let's just do this straight up, Jeff. Just do it straight up. There you go, buddy. Plus cx plus dx squared minus 2dx plus d. Is that cool? Just, okay. I was trying to be all, no, I'm not going to try to be all anything. So you get a plus c x cubed minus, let's see, where's my x squares? There and there. So I get plus d minus 2c x squared. Where's my x's at? Let's see, c minus 2d x. And then I get plus d minus a, right?
How did you get cx cubed?
Where's that?
Cx
Oh,
times x squared.
this c kind of gone into cx.
Oh.
And the c sort of became the
Alright.
parenthesis. And of course, this is where you just start doing your systems of equations, right? All right, now anybody get lost on any step up there? This step is something that people kind of don't even realize you're allowed to do. there's no reason B should show up anymore, because we know what the hell B is. So then what do you do with this shit? Well, you just bring it over. Right? So now what's A plus C?
1.
1. What's D minus 2C?
-10.
-10. What's C minus 2D?
11.
11. And what's D minus A? -2. And now you just solve this however you want to. Do you see how I have a D and an A? And do you see how I can solve this for C and plug it in here, and then I have another D and A equation? Yes? Not D and A, sorry. D and A equation. Because how do you solve system of equations? You try to get, bless you, two that have the same two variables in it, because then you can just directly kill or whatever between the two of them. I'm going to assume we all know how to do systems of equations. And of course, the matrix step is always available to you also. Is this step a problem for anybody, or is everything I did up here okay? Maybe you guys, yes.
Okay, so for the really long equation where it's like a times x cubed minus 1, do you just ignore the non-x's?
Oh, so here?
No, where it says ax times, that part, yeah, so the -1. So you're just ignoring the -1?
Sorry.
Because it's a,
No.
No,
He's got,
Negative
he's
A,
got
yeah.
This is
D minus
ax
A.
cubed minus a, correct?
yeah.
So there's my minus
Oh,
a down there.
okay.
So I'm just collecting my x cubes.
Got it.
Yeah. So show yourself whatever you need to show yourself to collect stuff together, right? To me, I'm tired enough that I couldn't do what I wanted to do here, so I backed up and just did it very, directly. Very good. Yes.
You have to so once we get all the values and we have to integrate it, we'd be able to how would you integrate the last one, the cx plus d?
Yeah. How would you, if you had to integrate this? How would you integrate this?
Would you just bring everything?
We did one exactly like this earlier. Completing
Oh, complete
the square. Yeah. It was almost exactly like this,
Yeah.
except yeah.
Okay.
Thankfully, I didn't ask you to integrate this, right?
Yeah.
Now, is there anything that could be on the top of this that you wouldn't have to use completing the square? So what I'm asking you right now, and again, real quick, any other questions on any of this and how to move forward? And of course, I got the answer key, so I got it all figured out. But real quick, if I had to integrate something that was over this, is there any top that would make this instead of 0?
X squared plus x plus 1.
See it? That's the next best thing is the same, right? Is there a linear function I could put on top?
X cubed plus x
Two.
squared plus.
2x plus 1.
Oh, so anything that would cancel with this?
Oh,
Yeah.
What if it didn't
2x
cancel?
plus
What if
1.
it's
2x plus 1.
yeah, 2x plus 1? Why is that a beautiful top to see?
It's the
Because
derivative.
it's the derivative bottom. So you let u equal this, du is that. That's the one time the answer does come out to be natural log. Right? If that was like this, that ain't no natural log. Right? Do you guys? Because you can't make it become a 1 over u through a u sub because it doesn't have the x piece it would need. Maybe? So then you'd have to do completing the square. Yes?
I was gonna say if we can do this by parts, but that wouldn't work because that's the denominator, not the numerator.
Yeah, you can't, by parts doesn't really work because there's really only one chunk. So you can try to make this u, but then du would be horrendous, right? If you make it dv, then that's the problem, so it doesn't really help us. Okay, maybe. Okay. There's one other problem I do want to talk about, but any other specific questions on that test? In a few minutes, I'll give you the key so you have time to look through it. Yeah.
Not really on the test, but on the homework. Can we do 7? I think it was 7-4, number 70 something. 72.
Oh yeah. Okay. So real quick. Okay. So everybody got what they want, and this is going to be on the answer key, so you didn't have to copy it. So this is one of those, they really love these integration
I mean, you just plug
problems
them
with n in it.
in. Do you know how to plug them in? Let's just use a full year again, okay? You just do this.
Don't be older kids. X squared plus a squared, yeah.
And then you
11
plug
when we
everything in.
started, John.
Oh, cool. And
A
then you
squared,
go
X squared plus a squared to
here.
the end.
And then you go ref, double R,
And it says use
and you grab your function.
integration by
And
parts
it gives you the answers. That's A.
to show
That's
this.
C, that's D.
Now,
That's so cool.
you can kind
That's
of
pretty sweet.
back engineer what they made U and DV, yes?
Why would you be X?
Oh, just because. The book puts the DX up here. I kinda
Double
don't like it,
DX.
so I wouldn't even think of it. They give you the answer that you get when you do by parts, right? So if you look at number 72, they actually give you what the answer is. You can sort of tease out what they must have let U equal and what they must have let DV equal, right? But, I mean, even if you didn't have that, what do you guys think I would let U equal? What's almost the only thing I can let U equal?
X squared plus A squared?
No, I'm not doing a U stuff.
Oh.
There is no X squared plus A squared to the end.
Oh, the whole thing?
There isn't. There is no spoon. There's a 1 over this. So by parts means take the whole chunk. I can't let U or DV equal this. So I really almost the only option I have is this. So then you figure out what DU is, right?
Yeah, I think so.
And what does that do for me? It decreases, well, I don't know, you have to see. So what would DV be then?
No, how much did you do that? Yes.
What's the only thing left for DV?
DX.
Yeah.
Yes.
DX.
So again, the nice thing with that problem, and this is number 72,
I don't like this.
right? 74, that is the one you asked me about, correct?
72, yeah.
Okay. They give you what the answer looks like. So you can tease out, they give you this, but they don't have, they have stuff. So you can actually figure out what they must have let DV equal. You can figure out what they must have let U equal. Kind of back engineer it, and that's sort of like what they want you to do. But really, that's the only thing you can let U equal. So it's really just let U go that, let DV go that, and then just construct this and see that it's the same thing that they have. Yeah, that's all they want you to do, yes?
I actually have another question. It was an integral of the absolute value of e to the x minus 1. That one was really.
Wait, oh, okay, beautiful. All right, so this is a little, one of those weird little end problems, right? They love to show those. What was it again? Integral of e to the, absolute value?
Yeah, integral of the absolute value of e to the x minus 1.
It was from what to what?
No, not the minus 1 wasn't in the.
Oh,
It was a constant.
like that?
Mm-hmm.
And was it from something to something?
It was from -1 to 2.
Yes. -1 to 2. All right. Why is she so excited? Real quick. Did somebody just go off shit? Can somebody tell me what that is? Nope.
The absolute value of X?
Say again?
The absolute value of X?
What does it equal?
Isn't it piecewise
Be
function?
more specific than positive. All right. I don't agree with you though. Could be 0. Does the absolute value do one thing to things? Does the absolute value do one thing to everything? What's it
Yeah.
do if the input is positive?
Keeps it
Leaves it alone. If the input is already positive, it leaves it alone, correct? So what did I just say? If the input is already positive or 0, then this leaves it alone. What does it do if the input's negative? Multiplies by -1. That's how you change a sign. You multiply by -1. So this weird little dude, and to be honest, I sort of have I kind of wish we never created this function. Because it's hiding the fact that it's actually two things, right? But you know, that's weird. I'm weird. So this, where is this 0? Because that's where it changes signs.
One.
Where is this 0?
At 0.
Yeah, at 0. And is 0 in here?
Yeah?
So then you have to go from -1 to 0, and then from 0 to 2.
What?
What's up? This should not be a surprise. Can't I break up any integral to any point in the middle of the interval that I want to. Because all this is find the area, and so I can break it up into this area and that area and add them together. Not a big deal. Yes?
Just seems like a bizarre step.
What do you mean? What I did right now?
Yeah, I don't know. It just seems weird.
So if I had to figure out this area, wouldn't you
Uh-huh.
find the area of the triangle plus the
Oh,
area?
because you can't differentiate at the where it changes in an absolute value function? Is that way you have to break it up?
I have to break it up because, now listen, from 0 to 2, what's true about this number? Is it positive or negative?
Positive.
It's positive. Yes? From 0 to 2, that's 0 or positive, meaning the absolute value, what does it do? Nothing. From -1 to 0, this number is
Positive.
negative. So what's the absolute value do then?
Multiply by negative. Ooh.
I just wish I could think of this
Maybe.
on my own.
Yeah.
The function
Yeah,
is
me
not
too.
the same across the entire interval. So you have to do one integral for when it's this,
Yep.
plus another integral for when it's this.
Mhm.
That's how every absolute value works. Now, if I would have said from 3 to 5, I would have just taken the absolute values away and not worry about it. I could use one interval because it's positive over that whole interval, yes? But it's because the interval they gave me included where the damn thing changed sign. Damn it.
I don't know.
Break it up, right? Maybe. Yes.
And you have to do this because on an absolute value function, at that 0 point, it's not differentiable? Like, that point doesn't
No,
really...
that's nothing to do with it.
Okay.
Not a
Then...
thing to do with it. I really want you to understand. I'm not trying to differentiate anything.
They're just two separate functions.
If I have this, isn't this just, and I want to know this interval,
Uh-huh.
isn't this just two triangles?
Yeah.
This being not differentiable doesn't matter to me. We're shit, right? Doesn't matter. It's just an area. Who cares? So
Okay.
I'm not doing it because of that. I'm doing it because the function I'm actually using is different based on what my inputs are. And again, do you guys understand now why I wish the absolute value was never invented? Because it looks like one function, but it's really two. Nah. Just seems like a trolly thing to do, but too bad for us. So that's why I love to ask this question, because people just say x. But x could be negative, so there's no way the absolute value of x can be negative, so shit. Okay. Is that better for them?
Mm-hmm.
What
Yes.
question was this?
Oh, I don't know. What question was it?
72 on chapter 7, right?
72 again? Wait.
No, it was 30 on 7.5.
Oh, I was remembering the last
75,
one.
Number 30.
My bad.
Yeah.
So off.
Does that make sense now, though? I mean, I can't integrate something that I don't even know what the function is I'm working with. And an absolute value hides what the function actually looks like based on what numbers you're using.
Hmm.
It's an evil little dude. Yes. Yes.
Can you explain one more time how you got the first equation? The 1 minus e to the x?
Yes. What's the absolute value of negative 4?
4.
4. Negative 4, correct?
Yeah.
So if the input is negative, when is this input negative? When this is less than 0. So when e to the x is less than 1. And when is that less than 1? At 0 it is 1, so less than 0 it's negative.
Yeah.
So if the inside of this is negative, from -1 to 0, the absolute value is going to change the sign.
For everything inside of it.
Say again?
So it's changing the sign for both.
Well, it changes the sign of the number inside. And what's the number inside? E to the x minus 1.
Yeah.
So it changes that sign, 1 minus e to the x. Yes. And of course on this side, every input is positive. So it's just, you can just take the absolute values, because the absolute value won't do anything to a positive or 0 number. Yes?
If there was more than one number that made that 0, would you have to split it up again?
Yes. Sorry, yes.
Crazy.
So if this was quadratic in here or something, that's quite a joy.
Exciting.
Exciting and right? I mean, shouldn't you, if I have a parabola, where is this positive? Everything below this and everything above this. So you'd have to, if I wanted to go, if there was the absolute value of some parabolic function, I might have to break it up from here to here, and then from here to here, and then from here to here, right? Okay. And it could get worse than this, obviously. More twists and turns. Enough of that, though. It wasn't, so that's happy. Yes?
We did 2D in the practice test.
2D?
The indefinite integral.
D is in duck?
Yeah.
Oh, that one, okay, good. That's the one I wanted, okay.
This one looks fun.
Alright, I'll step through this with you, and then I'll give you guys the answer key. What is it? It's a +1 on top, is that right?
Yeah.
Yeah.
You know, the number 3 is my nemesis.
That looked fine.
Okay, there we go. Actually, I think every letter and number is my nemesis. That's all, just all the numbers, all the letters. So, this one is a little crazy. Anybody have, and again, I remember I said this is sort of related to the earlier problem where we sort of forced the du to show up, right? So, and by the way, go through all your steps. Is it a straight up integral I could do? No. I don't know what the derivative of what is this, right? It's not like integral of secant squared or something. Yes? Is it something I can simplify? Maybe?
No.
Maybe, but nothing that would be really useful. Yes?
Can we multiply by the, what's it called?
Conjugate, that's what I was thinking too.
Okay, so two things. That only works when I'm involved and when I'm working with even powers or like squares and stuff. That has to be related to difference of squares. Does that make sense? So if I multiply this by this, will that make the irrational part go away?
No.
No. But if it was this, will the irrational part go away now? Yes, because this makes a whole x, and then the only other place the irrationals can hide dies in the middle term. That's a good suggestion, but it doesn't work for roots that aren't even or aren't 1/2. Yes? Do you have a suggestion?
We're gonna do a u sub, and then we're gonna force the derivative.
Yes! So what do you guys want to let u equal?
X to the 1/3.
X to the 1/3. Okay, let's try it.
Well, we can get a constant out of the way too if we put in the minus
Yeah,
1.
so the main thing here is, you could make it x to the 1/3, or you could make it x to the 1/3 minus 1. So which way do you guys want to try?
Minus 1.
Okay. And I like that, it's not a bad idea, because then the whole bottom becomes u, which is more doable, right? When the bottom is one term, then I can do more with it. Why not? So what's d?
1/3 x to the negative 2/3 dx.
Big ass. By the way, what is x to the 1/3?
U plus 1.
U plus 1, okay. Just keep that in your bag. And by the way, what is x to the 2/3, for example? Okay, then you can do more with that.
Wait. Oh.
What's up?
I see.
Why is it 1/3 x to the negative 2/3?
Because the power goes down by 1. You take a
Fascinating.
derivative?
Oh, I'm thinking about integrating.
Yes. Understood. It's like learning how to drive stick shift and you put it, oh shit, try to go in reverse. Okay. So, this is the semi-new thing we just learned today. And there's actually a lot, trig identities are infamous for this. And I'm really sorry if I just made some of you guys like a bad, whole sector of your life just came back. Trig identities, proving trig identities. You remember doing that stuff? Where you start with one side and you try to make it look like the other side. You guys remember that at all? So often, the way I would do it is, I know this side wants a cosine, so let me just pull a cosine out, or let me just make a cosine there and make everything else what I have to do, because I know a freaking cosine's supposed to be there. So, I know I need this for this to work. I need this, right? I need to find that so I can replace it with du. If I can't do that, I'm screwed, this won't work, I have to try something else. Does that make sense? I have to be able to find this. And this is another reason why I'm so sorry if your teacher showed you how to solve for dx and do shit. That is so evil. I'm sorry. It's a little evil, everybody. Because it's just so much better to go, I need to create this so then I can do something. If you just solve for dx and throw it in there, you're kind of lost as to what everything else is doing. Yes?
I was just gonna ask, can't we make the denominator like x to the 1/3 plus 1 times x to the 1/3 minus 1 to the negative 1 and do it by parts?
So just bring this up.
Yeah.
Maybe? That seems like, well, I mean, you could try it and show me. I'm not saying that this is the only way to do this. I'm open to other possibilities. I don't think that would work, but I haven't tried it. You never know. So, first thing, how do I make a 1/3 show up?
Multiply by 3.
Yeah, so I'm gonna put a 3 up there, so there's a 1/3 now here. So now I gotta figure out how am I gonna make that show up?
X to the 2/3? The positive 2/3?
What about?
Well, you just multiply by an x to the 2/3.
Yeah, okay, good. So if I put x to the negative 2/3 here, I can just multiply the top by x to the positive 2/3. Kick ass. It's probably better than what I was gonna do, which is just to pull an x to the negative 2/3 out of the top. But this is sort of like what we did earlier, right? We put what we want, and then we balance it. Okay, good. Let me stop for a minute. This is new. We're not used to this. But with radicals, this often works because they're related to their own derivatives in ways that a lot of functions aren't. Maybe? So watch what happens. I get 3 integral. This is du, yes? I'm going to sort of mix my x's and u's, which you shouldn't do, but too bad. What do I get when I distribute this? By the way, everybody cool with this being here? Why is this here?
We had to.
To counterbalance that. Why is that there? Because I need it for du, yes? Okay. This is very different from what you normally do with u sub, yes?
And it's positive, right?
Ooh, which one?
The one on the left.
Oh, this one, yes.
Yeah.
That's the only way that this and this would annihilate each other, so they're actually not even there. It's a dream. Okay. So what's x to 2/3 times 1?
X.
X.
Oh, that's why you have
X to 2/3 times 1. That's right, everybody. All right, so now let's do our substitution. And you really shouldn't mix the u's and x's up. All right. What's x to the 1/3 minus 1?
U.
U. What is x to the 2/3?
U plus 1 squared.
And what is x?
X to the 1/3 minus 1. Oh. U plus 1.
So to get
U
x,
cubed
3/3,
plus 1.
it would be
U plus 1.
u plus 1 cubed, yes? Which, by the way, if you had chosen to do not minus 1, that would have looked better.
Oh, that cancels out.
So that's all right. That's all right. This is not that big of a deal, right? What did I leave out? Thank you. Something I'm showing people as they come into the Math Study Center. Has anyone ever seen this?
Pascal's triangle.
Pascal's triangle, yes, right? So for example, x plus 1 squared is x squared plus 2x plus 1. 1, 2, 1, 1, 2, 1. So what good is it here? Well, what's u plus 1 to the 3rd? It's going to be all u, one of those, plus 3 u squares, plus 3 u's plus 1.
That's handy.
Done! What if I wanted to the 4th power? We'll just make the next row. How do I make the next row, Jeff?
Add
1. 1 plus 3 is 4. 3 plus 3 is 6. 3 plus 1 is 4. 1 on the outside. Right?
True. That's cool.
So then if I had a 4th power, it would be u to the 4th plus 4u cubed plus 6u squared plus 4u plus 1. It's a beautiful shortcut, right? Pascal's triangle is insane. Do you guys know Fibonacci sequence? You can actually find Fibonacci sequence in here if you do the right diagonals. It just really you just give that to a math teacher, let them sit in a corner, and they'll be like, oh my god. It's like a little, fidget for math teachers. All right, so now here, I want you. Let me see.
Is distributing them out the right decision to go with
do it
here
a little
though?
bit cleaner.
Do it. Sorry.
Instead of distributing, you can just say that x to the 1/3 plus 1 is u plus 2. Yeah. And then
Oh,
x
this
to
right
the
here.
2/3
Oh, yeah. It's even
x
better.
to the
Okay.
2/3 is u
X
plus
to the
1
1/3 plus 1 is u plus 2. Yeah. Okay, I like that even better. Okay.
And then x to the 2/3 is u plus 1 squared.
Yeah, x to the 2/3 is u plus 1. Okay. Actually, okay, watch this. You ready? I'm going to catch up to what you said. Can't I take u plus 1 squared out?
Oh no.
What would be left? U plus 1 plus 1? Okay, I caught up to you. But I love it. So doing that, you would have actually gotten here before me. Kick ass.
Wait, so you pull out u plus 1 squared?
Take 2 of these out, right?
Yeah.
So that I have 1 u plus 1 plus 1. Yes, what's u plus 1 squared divided by u plus 1 squared? 1. So if I take out 2 u plus 1s, I have 1 u plus 1 left plus 1 u plus 2.
Oh, sweet. Okay.
Yeah, and now this is a little bit better. You FOIL that out, bring that in, divide everything by u, then it's just power rule stuff. Yes?
You have separated the fraction at the step previous, so u plus 1 cubed over u plus.
Totally, yeah. Yes, totally. It doesn't really eliminate work though, but you could, of course, definitely. All right, let me give you the answer because I can't even remember right now exactly how I chose to do this back when I made this. Let me see. There it is. What did you choose, Joe? Oh, I just chose u equals x to the 1/3. Neato. Oh, okay. Mine actually, I think mine is worse than this, but oh. There are
Great.
2 sheets to this, so let me see how this is going to work. Because the last problem's not one here, we did that one together. I think it's easier if I just do this. Well, maybe not. Oh, shoot, man. That sucks. Come on, guys. My printer started running out of ink, apparently.
Uh-oh.
Yeah, I know. This is the next page.
Special guys, here you go. It's all yours, just gonna go.
Oh, really?
Jesus Christ. Oh, let me see if I got this right at the beginning. A equals, I got negative.
Yeah, I got them all right because I didn't even do it. I had no chance to get them right.
You can't lose if you don't try.
If you don't play, you can't lose.
Exactly. 100.
Simple math, you'll get a bad grade. You know, this is kind of miserable.
It's kind of what?
I know it's not hard, but look at this integral. 1 integral, 2 integrals, 3 integrals, 4 integrals. How sad.
It's pretty.
It's a wasted graph item.
What do we do with the U though? Is what
The
I'm-
u on the bottom? Oh, you just split the whole thing up into 4 integrals.
So, something you should have picked up on
Yep.
when you
Yeah,
took
you're right.
when you took pre-calculus is that you're going to run into problems that don't fall neatly into any of your known, oh, this problem, you do this, right? And that's what students want, and I understand it. You want, just give it to me like this so I know exactly what to put where and so forth, and that's just not the way it's going to be. On a test, I try desperately to give you problems that if you run through things like I told you to, so when I give you an integral, it's the very first thing you try to do. Simplify the function, right? So, for example, I think that this is my example I gave you before. If I had this, oh, Jeff, that's bad. This.
What's that? ln cubed?
Yes.
ln x cubed.
It's ln x cubed, yes. What's one thing I could do before I start doing any methods or anything? Put a 3 down. That's much better. And then this would be by parts, and some of you guys might even have memorized what the integral natural log x is by this point, maybe no?
Natural log X?
X ln x minus x.
No.
Plus c. Yes.
Oh, yeah, I sort of memorized that, I guess.
Real quick,
But if
I'm
you ever
sorry.
ask me, I wouldn't know.
So when I give you an integral problem, you first try to simplify the function. If you can't, which meaning
you know, like if I gave you a problem, I was gonna do this and I forgot, darn it. I was gonna give you this big ass, like, x cubed, blah, 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 x over blah, blah, blah. And if you just factor it, like almost everything cancels, right? You follow? So, any integral I give you, just stop and say, is there logs that I can use? Is there polynomials I can try to factor? So, you know, just take a quick second and see, will it reduce? Can I make it simple? Right? So, first thing, that's the first thing. Second thing, is it just a straight up integral after I simplify, right? So sort of like integral tangent squared. You can make the integral secant squared minus 1, straight up integral. I don't need any help from u sub or I don't need any help because those are just straight up antiderivatives. You with me? Yeah. If that doesn't work, then you rule out, you always go to u sub. That's the easiest of all the extra methods that we've learned, right? So how do you even rule out u sub? Is there a function in there whose derivative is also in there? Now, there are more levels to u sub, obviously, yes? Mm-hmm. I don't tend to give you a bunch like this, because then it's sort of like you just have to kind of realize the thing you can do. You with me? But I do try to give you u sub problems that are kind of on the obvious side. So if you see tangent and you see secant squared, it's a u sub problem. U equals tangent, du is secant squared. Bam, right? And then of course after that, then you try by parts, right? And then you got, you know, and also I think the form of trig sub. Does everybody understand what to look for? So for example, which one of these would you use trig sub for? Definitely. Which one could you use trig sub on? Both. Which one should you probably do a different way?
This one, right?
This one, right? Now, if it was this, does everybody really see what that's obviously, anybody see, that's obviously what? U sub. Because there's a function that's sort of stuck somewhere whose derivative is in there. Now, the derivative of 9 minus x squared is not x, but does everybody understand? It is x. The constant doesn't really matter because I can always make it whatever I need. Okay. If it's this, what's the trick there? I can solve for x squared. So the x that would be the derivative of this guy, there would be an extra x squared that I can also replace with u. Are you guys kind of with me? Okay.
Wait, can you do that again?
So if I let u equal 9 minus x squared, what's du?
It's going to be just
Negative 2x, so 1/2, negative 2. I can take one of these x's and this negative 2 over here. Doesn't that leave x squared? But x squared equals 9 minus u. So I can replace the whole thing with u sub really is, can you make all the x shit become u shit? That's what u sub is. If you can, it almost doesn't matter how you do it. Except it's got to be, you know, mathematically legal, right? Okay, maybe. This one is a definite what? Trig sub, right? And they do normally have a very specific look. There are the ones you have to complete the square for, right? But they normally have a very specific look to them. So you can pretty much bypass everything. If I gave you this, you can't simplify it. It should be an automatic kind of like, oh, it's a trig sub. It's a classic trig sub. Amazing. Yes, exactly. It's just gonna be 3 sign, blah, blah, blah. I'm sorry, so what?
So I was just saying, like,
I'll think a
this is,
lot of
kind
stuff
basic,
about
but going
that
back,
one.
like, what's the integral of e, like, for example, negative 4x? I always get confused on how to go back on e.
All right, so real quick.
Yeah,
Let me show you.
but,
Let me show you the way I really don't want you to do it. But this is valid. U equals negative 4x. What's du?
I got the same thing as you.
Negative 4 dx, right? So then I need a negative 4, so I put a 1/4 negative. And so I got my negative 4 here. So it'll be negative 1/4 integral e to the u du. Integral e to the u is e to the u, so I get e to the negative 4. Yeah, like, yeah, plus u, right? Now, you don't need to do all that shit. the integral of e to the negative 4x is e to the negative 4x with some extra something. Why do I know this is not the answer? Because the derivative of this is not this. What do you pick up when you do the derivative of this? It's
Negative.
not here.
Negative 1.
So I better divide by negative 4 to kill the negative 4 that wants to come down. I get the same answer, just quicker, yes? So when the inside function is linear, you do not have to use u sub. It just makes it longer. If you're not comfortable doing what I just did, then go ahead, use u sub. It's not that crazy, right? But I really want you guys to get to a point where you're cool with just not even doing the u sub, but I'm not going to take points off if you do, right? You can still do it. It's fine. Is that all right?
Yeah, thank
Okay.
you.
So, how do we have VU in that problem on top like that?
Because I can do this, yes?
Yeah.
This is VU, right?
So wait, where you brought in an X?
No, I didn't bring it in. This was x cubed. It was x
okay.
cubed.
Okay.
And of course, x squared is u minus 9. So now I can replace all the u stuff, all the x stuff with u stuff.
Okay.
Yeah. And real quick, do you see how the bottom becomes one term? U to the 1/2?
Yeah.
So then I can
Just bring it up.
divide each piece by it, which is really what I'm trying to get to with a lot of the u subs. Yeah. Yes?
So since it's like e to the negative 4th x squared, you would have to divide parts of that, right? And then find the antiderivative.
Now, if it was this, that's impossible linked by hand.
Yeah.
Impossible. What's one thing I can add that would make it possible? X. Because then if u is this, the derivative is basically that, without a constant, but I can make that work. Yeah, so I would never give you this because that would be
But
control
if there
and
was
yes.
an x before, then you would do the by parts to solve for the.
Do it again.
Because let's say there was an x before.
So if it was this, that's by parts.
Okay, but if it was negative 4x squared.
That's by parts.
Yeah.
Yes?
Yeah.
Because it can't be u sub. Because it's got an extra x. U equal that would need a constant. There's an x sub. Shit. You guys with me? It's not u sub. That's u sub. The minute I do that, that's u sub now. Because the derivative of this function, I would let u equal this, is negative 8x. And I have the x piece.
Can you? Oh, never mind.
So some of you guys, the one quiz I gave you, a lot of some of your first problems were w e to the 3w.
Mm-hmm.
And some of you guys had w e to the 3w squared. So one was, and then there was another problem that one was by parts and the other one was u sub. So I made sure everybody had the same number of u subs versus by parts. But you guys understand what I'm saying? This would be by parts. U sub. Because there's a function whose derivative is in there. That is the most basic thing to look for to see if u sub is going to work. Is there a function whose derivative is also in there? There's more to it, but that's the most basic thing to look for.
That's pretty brutal.
Now listen, again, so as you're doing your homework, if it's taking you longer and you can't get in for help, you start sort of doing every other problem. Because the worst thing, I don't know if I had this discussion with you. Have I had this discussion with you about homework, making it your own? Yeah, I'm pretty sure I have, right? Where you do not want to come to the test with the entire sections not looked at. I've had students tell me, oh yeah, Mr. Waller, I know I missed those last 3 because I didn't do those sections at all. I'm like, what the hell? Why the shit when you do that? Just do every other problem that I want you to do. I'm not saying I'm going to be cool with it. I'm going to be like, finish this shit, right? But you're going to be like, whatever, man. I'm doing what I can. You with me? Because that's what I did. My God. My grades had a lot of personality because I could not do all the homework. And my teachers graded the homework on a high percentage. I just couldn't. I was working 3 jobs. I was supporting myself through college. There's no way in hell I was going to do all the homework. So I did just enough, and I kicked the test's ass, and my homework average brought me down. So I like to say my report cards had personality. That's what I like to say, right? And I'm okay with that because I understood the ideas. I just couldn't do all the homework. There's no way. So I understand that can happen. Just don't hurt yourself for the test. So yeah, I want you to do every problem. But you go, that's great for you, Jeff. I'm going to do what I can do, right? You got to make it your own. Okay, yes?
Better to finish all the homework or skip every other problem and then do just a practice test?
That's a good question. The practice test, at least, it's more important to do the homework. The practice test, definitely scan through it because it gives you an idea of how I like to set things up. Would you agree with that? Yeah, how I like to kind of give problems, and I like to mix it up a bit. And just to kind of checklist, do I understand what to do here? Does that look familiar, right? Yeah. What's due on Wednesday?
All the homework.
Homework through 7-8.
Yeah.
And?
Quiz
Quiz corrections that you haven't done yet.
Oh, I haven't done that.
Oh my God. All right. So if you have any more questions, we got more time. But otherwise, if you're done,
Sorry.
if you're full.